In the previous video, we saw how to make the character move from left to right when you touch the screen. But so far the enemies here, the obstacles don't do much, they stay totally in place. So what we'll do in this video is to code the movement of these obstacles for them to move toward the player. Here will be the challenge. The player will have to avoid these obstacles. For that, I go to the scripts folder, I'll right-click, create C# script, and I'll call it obstacles. I'll wait for it to compile, and we'll take this new script to drag it on the middle obstacle, because if you remember, the others are just temporary there as markers. I remove them later. Now the script has been added, and I double click to edit it, and we'll write the code that will make the obstacle move towards us. First of all, the using here is everything we want to use in our script. For example, using Unity engines, it gives me access to a whole bunch of Unity engine's functions. If I didn't have this, it won't work. Mono behavior will not be recognized, for example. If you remember, we imported Text Mesh Pro, so I'll declare a using of TM Pro, Text Mesh Pro, which will allow me to access the features of Text Mesh Pro, because I want, for example, to be able to increment the player's score when he avoids an obstacle. And for that, I will need to access Text Mesh Pro. We'll need some variables, so I'll create a public float speed variable, which will be the speed at which the cube moves, and by default I set it to 10, which will allow me to have a pretty high speed, because since I'll be testing it a lot, I don't want to waste time waiting for the cube to come to me every time I want to test my code. So, as it's a float variable, it has to end with a small f. Then I'll create another variable. I set it to public to show you, but it doesn't have to be public, it has to be private. But it's just to show you that it's a variable that we're going to set by script, like on the fly, I mean. So it will be a variable of type TextMeshProU_GUI. Seems complex, but it's just a type of variable that is contained in TextMesh Pro, and which in fact is the text. It will allow us to access the text, and in this case the score text. And just call it text. That will allow me to access the score text, so I can increment the score when I need it. I go back to Unity, and in Unity I search for the score here. And be sure to check the name of your object. My name is score with a capital S. You can actually even call it score text, for example. Give any name to your score, but remember this name. We go back to obstacle, and here what I'll do is fill in text. I'll say that text is equal to GameObject.find. Find will allow me to search for a game object that is present on the scene. In brackets and in quotes, I pass the name of the object I'm looking for. That's why you have to remember the name you gave, because it's exactly this name that you have to put here to be able to search for this object by its name. So this function retrieves a game object, except that text is something of type TextMeshProU_GUI. So when I retrieve the game object, I get an error. I'm told that I can't convert. When I have retrieved the game object, I do a get component, .get component, which will allow me to retrieve a component of the found object. Between the chevrons, I'll say that I'm looking for TextMeshProU_GUI, and I end with a bracket. This allows me to retrieve that component specifically for that game object. This means that my text variable will be filled in automatically. We can test. I go into Unity, select the cube. Here we see that I have a speed and that I have text, which is completely empty here. I launch the game and look at the text. It's going to set itself. There, the text variable has been automatically filled in. And if I click on it, it selects score text here. And if I want, I can change the score, set it to 5, and you can see that it works. So we've managed to dynamically recover something. Why am I getting it dynamically and not putting it directly here? Simply because there will be no obstacle by default in my game. The obstacles will be generated by script on the fly, and so I need that when the obstacle is added to the scene, I mean when it's created on the scene, at that moment I need the script to go through the objects of the scene to find the score. So that's why I put myself in the start function, which is triggered from the moment an object arrives on your stage, in your scene. So when the cube is generated, we get the score and we store it here to use it later. There are many other ways to do this. This way is not necessarily the most optimized, but I wanted to present you this GameObject.find function, which is really, really useful. I try to vary from time to time when I have a problem to solve. I try to present you different functions each time, but GameObject.find is one of the solutions that we can use. There are other solutions, but well, I'll show all that when I get a chance. That's all we need to do in the start function. Now I'll go into update. I need to do a translation of my object. My object is the object that the script is attached to, and I'll do a transform.translate. This will perform a translation. The object will perform a translation, which means that it will move in the 3D world. This translate function takes some parameters, takes the direction, and the direction is a vector3. So I write vector3.back. Back is part of some properties that are by default in vector3. We also have vector3.up and vector3.down. Let me draw you something like this to be easier to understand. Here we have the cube, we have vector3.up, which is there, down, which is there, forward. Let's imagine this is the center of the cube. Forward will be something like that. I do it in dotted line because it's through the 3D shape. Forward is over there, dot right is here, left it's going to be over here, and back, the one we used, it will go from there and it will come toward us. Vector3 has all 6 possible directions, and by making a dot back, it will make the cube move towards us. If you look at the 3 axes, red, green, and blue, each axis has 2 possible directions. 1, 2, forward and or backward, up or down, to the left or to the right. So each axis has 2 possible directions. The blue axis is the forward axis, if you will, which points forward, and if I do forward, the obstacle will move away from me. Whereas if I do back, it will move towards me until it collides with the player. That's why I write a vector3.back. Then we'll multiply that by time.delta_time. This is very important. Remember this. Time.delta_time will allow us to calibrate the speed, because depending on the power of the computer, the game will run more or less quickly. On a very powerful computer, the game will run very fast. On a less powerful computer, the game will not run fast at all. This means that the speed, the obstacles will not be the same depending on the computer you are using. Someone who's using an old computer will have the advantage because the game will be so slow that he will see the obstacle like 10 minutes before and will be able to avoid it easily, whereas for someone who has a very, very powerful computer, it will go so fast that they won't have time to avoid it. Multiplying something by time.delta_time allows to calibrate the speed, so that the speed is the same no matter how powerful the device running your game is. So when you multiply a speed by time.delta_time, it's calibrated, and it will be the same no matter how powerful the machine is. Then we'll multiply that again by speed, speed being our variable that determines how fast the object moves. I press Ctrl S and we will test. Back to Unity, we'll let it compile. We'll look at this one because it's the only one that's affected by the script. And I'll launch the game and the cube is going to move. Let's have a look. Here we have the obstacle coming towards us. You also see that for now all collisions are ignored and the movement is infinite. In Unity, we have all the collisions that are managed. We already have a box collider, except that unfortunately the collisions don't work depending on how the movement is done. We have the possibility to make a movement in several different ways. And it happens that we did it with transform.translate. And with that one, the collisions will not be detected. So in order for the collisions to be detected, we'll need to add a rigid body. I'll go to Add Component, Rigid Body. My obstacle will have a rigid body. I'll uncheck Use Gravity because I don't want the rigid body to be used for gravity. I just want it to be used for collisions. The rigid body has some features that will detect collisions in cases where it's not possible to detect the collision with a simple box collider. You have several ways to detect collisions, more or less expensive in resources. In the collision detection here we have discrete. We can have continuous. I'll select that one for more safety. Because it has a better detection, even if it is a little bit more resource intensive, but it's not a big deal. I'll add a rigid body to my character, which will not be affected by gravity. And we add a rigid body here, which itself will not be affected by gravity as well. So now I'll be able to handle collisions. I'll test it to show you the difference it will make. There you go. You can see that here we have collisions that are managed. Well, it's a bit of a mess because for now we only told this cube to move forward, and it will move forward to infinity and beyond. And as we don't have gravity, the objects keep their propulsion, if I can say that. That's why it's a bit of a mess. But what comes is that the collision is now well detected. If you don't want everything to break, you can actually check the iskinematic property, for example, on the end obstacle. And by checking this iskinematic property, the shape will not be affected by external forces. See, like this, so it doesn't move. That doesn't change the fact that everything is broken. But as I said, it doesn't matter. All I was interested in was detecting the collisions. Okay, I go back to my script, and now that I know that collisions are detected, I can use the onCollisionEnter function. This is a function that fires when a collision is detected. It's a reserved function in Unity, and it's something that triggers itself when the collision is detected. When the collision with the current object is detected, and this is our obstacle, and in brackets, it returns the collision, meaning the object that we collided with. If you look closely, here we have an object, which is not named. I'll name it right now. It's called cube. I name it player. And we have an object here, which is called out. Again, remember the name of your objects, it's very important. So when we have a collision that's detected, I'll write if collision, which returns the collision, dot gameObject, which returns the gameObject with which we collided, dot name, which returns the name of the gameObject resulting from the collision. So if we collided with an object whose name is equal to player, this is me naming my player like this, I'll write destroy. I'll destroy collision.gameObject that corresponds to the player, meaning I'll destroy the player. Let's copy that. And if collision.gameObject.name is equal to out, so in the case that we collided with out, which corresponds to the cube that's behind the player to say that we avoided the obstacle, I'll do destroy of gameObject. Destroy of gameObject, it means that I destroy the current gameObject, meaning the obstacle. So In one case, we destroy the player, in the other case, we destroy the obstacle. But before that, what I'll do is increment my score. My score is an int, so I'll create an int variable, which I'll call new score. And I'll say that the new score is equal to the current score. The current score is stored in our text here. It's text.text. It's the text of our object, which is called text. If you look at our game, we have our text here, score text, which also has a text property, which contains a number. Unfortunately, this text, well, it's a text as the name indicates, and it's not an int at all. You can't say that an int is equal to a string, it doesn't work, but you can convert it using int.parse. I already told you about it. Int.parse will allow you to convert a string into an int, and there I don't have any error anymore. So what I'm saying is that the new score is equal to the old score. That's not good, that's not what I want. What I want is to win a point because we avoid one more obstacle. So I say that new score is equal to the old score plus 1 to increment by 1. Then we can define the new score. I'll say text.text is equal to new score. So that means that my new score becomes my current score. Here, I have an error because I have the opposite from before. I can't convert an int to a string. Basically, here you can do the reverse, and this is the same. On the one hand, you can set a text to an int, and on the other hand, you can set an int to a text. It's not possible. So what you can do is use the toString function, which allows you to convert the int we have here into a string. And there, the problem is solved. I go back to Unity and we will test. We have a score of 0. First, I will let the obstacle destroy me. Okay, poof, here, the player is destroyed, so that works, and now I'll avoid the obstacle like this. The cube is going to collide with the out object, and there I have a score of 1. You can see that my score has been incremented. Now, you know how to create a system with obstacles that come towards us and destroy us if it hits us, or that are automatically destroyed, and it increments the score. That's it for this script, and I'll stop here for this video, but we'll go a little bit further in the next one to keep improving this whole system. But, you know, have a base here that allows you to have something functional, and well, see you in the next video to continue this.